What is up? Good evening. कैसे हैं आप? We are going to be talking about the atomic structure. And hold on, I will just remind my friends on Discord that we have started the session. How you doing? How you doing? So, if you're wondering what I'm talking about, what's Discord and all of that, yeah, don't worry. Link है sessions description में to all my sessions in general. So why are we starting atomic structure? Well, हम लोग whole concept खत्म कर चुके हैं. Yeah, that's why we're starting atomic structure. Also, I honestly feel that atomic structure should be done a lot later, like the 7th, 8th, maybe even the 9th chapter towards the end of this 11th grade, because उसको समझने के लिए you need a lot of other things from physics. You need waves, you need this, you need that, you need. But we'll try our best कि हम लोग जितना भी समझ सकते हैं समझ लेंगे. एंड डोंट वरी, रिविजिट इट. फिजिक्स में जो एंड में बिल्कुल है, इसको मॉडर्न फिजिक्स बोलते हैं ना, वहाँ पे भी फिर से आएगा एटॉमिक स्ट्रक्चर. इट्स द सेम थिंग. या द रीजन फॉर यू टू डू इट बिकॉज ऑफ द एग्जाम पॉइंट ऑफ व्यू, वेदर यू आर डूइंग जेई नीट कोई भी एग्जाम, कि भाई मॉडर्न फिजिक्स आता है और यहाँ पे आता है तो इजी मार्क्स यार. प्लीज स्टडी एटॉमिक स्ट्रक्चर, डोंट स्किप इट. दैट इज वन आइडिया. ऑल्सो व्हाई डू यू वांट टू स्टडी इट एज अ साइंस enthusiast? It is literally what makes everything around us tick. I don't know if you've seen the movie Oppenheimer, right? There's a scene where he talks about what are we actually, and he says we look like we're solid, but at the atomic scale, there's so much distance between each particle, because it's almost like there are just individual particles really far away alone, but then you put them together and you see us, and it's crazy. That's exactly what it's like. But you don't think about all that in day-to-day life, but it's very, very relevant to you when you try to do some crazy state-of-the-art stuff. Yeah, थोड़ा ज्ञान देना बनता है. Hare Krishna, Rishabh, what are you doing here? That's awesome. Thank you. Welcome. Shaveta, hi. Student Ash, welcome. Right? I know, Rishabh, and it's a fair thing to do. It's a fair thing to get very annoyed with this. So you're able to hear me and see me clearly, right? I think I'm wearing a mic in the right place. Yeah. It's fair thing to get annoyed with atomic structure, because philosophy aside, बहुत ज़्यादा चीज़ें हैं जो आपके ऊपर क्रैम कर दी जाती हैं. I will also do a little bit of it because you can't escape it. And the reason I'm doing it because it help you in school, because everybody I know has already doing atomic structure or पहले periodic किया, whatever. It's somewhere in the starting of 11th. That's why I'm doing it. But the philosophy wise, it's wonderful. When I was in school, तब the catchphrase was nanotech, right? When I was in school and college. आजकल the catchphrase is quantum. Watch any movie. Marvel made a movie about it. What is that? Quantum Mania was a very bad movie, but they made a movie about it. There's a popular book called The Three-Body Problem. Talks about quantum superposition, the Schrodinger's cat being dead or alive. All of that is a lot of pop culture people have been using it. And latest, just as of yesterday, I saw a video on this article. Basically, it was talking about the origin of consciousness being some sort of quantum tunneling happening in the brain. What on earth is quantum and what the hell is tunneling, right? Maybe what I want to do is to generate some sort of interest आप में, कि आप खुद जाके ये सब चीज़ पढ़ सको. ठीक है, अभी हम लोग atomic structure शुरू करते हैं. All right, good. Thanks for being here. Let's just get started. There are some things from the JEE and NEET point of view. There are a lot of things that have been removed from the syllabus, even from this chapter. Okay, what has been removed? I'll show you पहले क्या हटाया गया. ठीक है, रुको. ये हटाया गया. ठीक है, न्यूक्लियस this ये सब चीज़ सब हट गई है. न्यूक्लियस में क्या होता है, रदरफोर्ड मॉडल क्या होता है, ये सब चीज़ हट गया. ठीक है, तो मतलब है क्या, व्हाट इज इन योर सिलेबस? विल गेट टू दैट. ठीक है, विल गेट टू दैट. दिस इज इन योर सिलेबस, जो मेरे सर के ऊपर लिखा है. डोंट वरी, दिस इज इन योर सिलेबस. बट व्हाट इज नॉट इन योर सिलेबस? Millikan's oil drop experiment. Is this in your syllabus lab में? I don't think so. Anyway, so there were a lot of experiments done, but JEE और NEET ने और JEE Advanced ने भी डिसाइड किया कि भाई ये सब हम लोग नहीं करेंगे. ठीक है, तो what will we study? Let's start from this point, जो मैंने आपको जो है मोल कॉन्सेप्ट में भी बताया था, कि mass of an electron was figured out by doing some crazy experiments charged by mass के through. Okay, so don't know about mass, we don't know about charge, but we were able to somehow magically do charge by mass. I know this is an abrupt start to this chapter, but I'm at a weird place. They've removed so much of a syllabus, so I'm just saying पुरानी NCERT निकालो और पढ़ लो if you want to know the history part of it. But I think already कर चुके हो 9th और 10th grade में. You have done all of these things. Rutherford's experiment कर चुके हो आप लोग, alpha scattering and all of that history, right? Dalton's atomic model, etc. ये सब चीज़ पढ़ चुके हो. खैर, let's start here. Let's start with this जो हम लोग ने mole concept में भी देखा था. If you attended my first couple of sessions on mole concept, you would have seen all of these things. There's a mass of an electron and mass of a proton. But ये सब पता कैसे चला? I mean, it's just really small numbers, right? And what does it mean to even talk about these? Do they matter? इतना छोटा सा mass, इतना छोटा सा charge, does it matter? Well, by themselves, the mass of the charge may not matter, but there are so many of them. By mole concept, हम लोगों ने पहले mole concept किया है. You need to multiply all of them by approximately this magnitude, right? This order of magnitude. then they make a lot of sense. Then they become real and scary. Like they become real things, like my hand right here, and they're not atoms anywhere. All right, see you, Rishabh. Good evening, Benita. How are you doing? Advanced के लिए deleted syllabus not. Student dash एक बार देख लीजिए. I feel that atomic structure का जो deleted part है, that's not necessary. Generally, that's not the case. Yeah, P block का मैं revision sessions कर रहा हूँ. मैंने अभी group 13, group 14 किया था. कल मैं hydrogen S block metallurgy करूँगा. So not generally. Oh, congrats, Rajanya. That's great. That's great. That's great. Thanks for sharing it with me. Hey, we are on the JEE channel. Oh, you are from, that's great, that's great. Yeah, by the way, this session is relevant to everybody. JEE लिख रहे हो, NEET लिख रहे हो, कोई भी एग्जाम लिख रहे हो, it is relevant to you. The main idea here, okay, now let's focus on आज के हम लोग क्या बात करने वाले हैं. We will do 2-3 things. Let me just give you a broad overview of how we're going to approach this chapter. This is the first lesson of this chapter, right? हम लोग देखेंगे, you will see the name of this topic is electromagnetic waves. What does that do to the atomic structure? We'll get to that. Then light की बात कर रहे हैं. फिर अगले सेशन भी लाइट की बात कर रहे हैं. नेक्स्ट सेशन ऑल्सो इज देयर ऑन थर्सडे. लाइट एज अ पार्टिकल. व्हाट डज दैट डू एटॉमिक स्ट्रक्चर? So this is the craziest part, and this is where things go right. Light, you have an idea about this, behaves like a particle and a wave. And interestingly, particles can also behave like particles, obviously, and as waves. That is the part that's interesting in atomic structure. Yeah, particles behaving like waves and particles behaving like particles. That is what ties into the atomic structure part of it. वो last part होगा इसका, which is quantum mechanics, which is what will help you understand pop culture, movies and references better. ठीक है, तो अभी हम लोग शुरू करते हैं. बट व्हाट डू वी नो इवन विदाउट ऑल ऑफ दैट? व्हाट डू वी नो? फिजिक्स में आप लोग को थोड़ा बहुत आइडिया है, मे बी 12th में आइडिया होगा, बट आप लोग थोड़ा बहुत इलेक्ट्रोस्टैटिक्स के बारे में जानते हैं. मतलब बाल पे लगा के वो बलून को रब करो तो उसमें वो चार्ज आता है, इट गेट्स स्टक टू स्टफ, राइट? सो दैट चार्ज इज क्वांटाइज्ड. व्हाट डज इट मीन? वो पैकेट्स होते हैं चार्ज के, राइट? देयर इज नो, इट्स नॉट पॉसिबल फॉर मी टू गेट something like 1.8 into 10 power minus 19 coulomb. That's not possible, right? The smallest charge is 1.6 into 10 power minus 19 coulomb, and I can have multiples of that, right? Some multiples of that. That's what this quantization business is saying. So quantum mechanics just means that stuff is in small packets. It's not a continuous thing, but the packets are so small that for most of us, like at macro scale, it looks like कि भाई सब continuous ही चल रहा है, right? ज़्यादा ज्ञान हो गया क्या? डोंट वरी. इफ एट एनी पॉइंट यू डोंट फॉलो समथिंग, यू कैन फील फ्री टू स्टॉप मी. एंड एटॉमिक स्ट्रक्चर थोड़ा फिलोसफिकल है, ठीक है? वी विल पुट अ बिट ऑफ मैथ टू बी एबल टू डू वंडरफुल क्वेश्चंस, बट इट इज अ लिटिल फिलोसफिकल, ओके? बिकॉज इट्स नॉट पॉसिबल फॉर मी टू गो थ्रू ऑल द मैथ और एनीबडी टू गो थ्रू ऑल द मैथ इन आवर लिमिटेड स्कोप ऑफ दिस. बट ठीक है, एटलीस्ट आई होप इस ये आप में इंटरेस्ट जागृत करेगा, जिससे आप एटकिंस जैसी भारी भारी बुक्स पढ़ सकें एंड लाइक वाओ दैट्स क्रेजी. लेट्स टॉक अबाउट सम ग्राउंड फाउंडेशन थिंग्स दैट वी नीड टू बिल्ड फ्रॉम फिजिक्स, जो इसमें करने में हेल्प करेगा, ठीक है? अब हम कर रहे हैं थोड़ी सी फिजिक्स, थोड़ा सा फिजिक्स, ओके? या व्हाट फिजिक्स आर वी डूइंग? वी आर सेइंग दैट ओके, दिस इज द स्मॉलेस्ट चार्ज एंड आई कैन हैव n ऑफ दीज चार्जेस टुगेदर, ओके? ये है इलेक्ट्रॉन का चार्ज और प्रोटॉन का चार्ज. इट्स अ नेगेटिव चार्ज ऑन इलेक्ट्रॉन, पॉजिटिव चार्ज ऑन अ प्रोटॉन, ठीक है? ओके. एंड या ESU में यूनिट है, एटसेट्रा एटसेट्रा. सो now what can happen if I bring two charged particles together, right? Say plus q or plus q minus q. What will happen? They will either get repelled, like charges will repel, and unlike charges will attract. भाई कर क्या रहे हैं हम लोग? कर लो अभी. This is important to get to energy. Charge gives you force, force gives you energy, energy gives you potential energy, giving you a bit of a, agar if you're in a hurry, like what are you talking about? And potential energy will then tell you, oh look at that. And with this, I can figure out the wave nature of light. Like, हाँ यार मुझे तो मालूम था light wave होती है. I know you know, but ठीक है. Just bear with me. Just bear with me. Parth भाई साहब, you can come check us out on this I Teach Chem thingy, which is my handle on Telegram and on Discord. We can chat there. अभी के लिए I'm going to continue talking about atomic structure. ठीक है? Please, I hope you don't mind. Because see, this session is live, but there are also going to be a lot of students who are not watching live. So for them, I'd like to continue here, and for you, whenever we do questions, we'll keep it live, we'll keep it interactive, okay? Absolutely, जो आपने बोला, yeah, नसरत अली, बिल्कुल सही, repel, attract. So like charges are going to repel, and unlike charges are going to attract. What I want to do is I want to figure out the force of attraction, ठीक है? And you will do this derivation in 12th standard कि कहाँ से होता है, क्या होता है, but this force is proportional to the product of the charges, the magnitude of the product of the charges. थोड़ा सा theory यार, प्लीज अभी डाइजेस्ट कर लो, कहीं से लिख लो, डोंट वरी. these notes I'll give you on the Telegram channel and also या इस वीडियो के लिंक में as it gets ends I'll post it. And it's inversely proportional to the square of the distance. मतलब जैसे ही चार्ज थोड़े दूर हुए तो ये अट्रैक्शन या रिपल्शन बहुत जल्दी से गिर जाता है. स्क्वायर, राइट? सी, if something is reducing linearly, you draw a graph that looks like this. अगर square है तो it drops like this. ठीक है, that's what we're trying to say. अगर बढ़ना हो similarly तो ऐसे होगा directly proportional. Square बढ़ेगा तो बहुत जल्दी बढ़ जाएगा. Same चीज, इसका उल्टा हो रहा है यहाँ पे. Okay, cool. Okay. So we put a proportionality constant and we will do all of these things. 12th standard में हमारे बहुत बढ़िया teachers हैं, सौरभ जी हैं, अभिषेक जी हैं. There are a lot of amazing people who will teach you all of these things in the 12th grade. This proportionality constant is called K. And this depends, there's something called permittivity and all. So it depends on the medium, okay, also in a way. ठीक है, अगर आपके पास फ्री स्पेस में है और चार्ज किसी और मीडियम में घूम रहा है, जो भी है, बहुत चीज़ें हैं, बट देयर इज सम वैल्यू ओवर हियर. ठीक है, एंड कुछ नंबर्स हैं, कुछ और स्कैरी चीज़ें हैं. ओके, सो विद दिस आई कैन गेट द फोर्स दैट इज देयर बिटवीन अ कपल ऑफ चार्जेस. ओके, मीनू दैट्स नॉट इन योर सिलेबस. मैतुल्य, व्हाट्स योर डाउट? You know, instead of saying things and then saying things, get to the point. It's easier for me to follow on the chat. Yeah. Parth ji, depends on your focus. If your focus is JEE Main and NEET, your best book is NCERT. If your focus is JEE Advanced, you have to read books that tell you more things in detail. Okay. There are authors that I like. You can find any author, but make sure you read it inside out. Yeah. Just checking chat over here. All right, thank you Rajanya, that's an interesting, cool, thank you. All right, ठीक है. So with this I have some idea कि ठीक है, अगर charges हैं, दो charges, just let's do 2 at a time. And you know what we'll do? We'll take 2 charges, then we'll take another 2, we'll take 2 more, we'll do 2 more, and then we'll add them all up together. How? Something called vector addition. Like, देखो ये दोनों इस डायरेक्शन में रिपेल कर रहे हैं, अभी दो और वो इस डायरेक्शन में कर रहे होंगे, इसको ऐड कैसे करोगे? There is something called vectors that you learn how to do that. Direction and magnitude. तो अगर बड़ा चार्ज हुआ तो उसका इफेक्ट ज़्यादा होगा, वो भारी इफेक्ट होगा, और अगर छोटा चार्ज हो तो इसका इफेक्ट कम होगा. दैट इज मैग्नीट्यूड. डायरेक्शन मतलब अरे दोनों सेम डायरेक्शन में तो ऐड हो जाएंगे, ऑपोजिट डायरेक्शन सब्ट्रैक्ट हो जाएंगे. ये तो एडिशन सब्ट्रैक्शन हो गया. व्हाट इफ इट्स लाइक दिस, व्हाट इफ इट्स लाइक दैट. ठीक है, ये सब वेक्टर्स में आप लोग पढ़ोगे कैसे होता है. ठीक है, सो वील टेक 2 एट अ टाइम, बट वील एक्सपैंड इट टू दैट होल NA पार्टिकल्स, मोल्स, राइट? दैट्स व्हाट आई टॉक अबाउट. ठीक है, दिस इज व्हाट इज हैपनिंग बिहाइंड द सीन्स. ठीक है, अब हमने फोर्स का थोड़ा बहुत आइडिया लिया. व्हाट डू वी डू विद द फोर्स? मैंने बताया था फोर्स से हम लोग यूज करेंगे एनर्जी, बिकॉज एनर्जी विल देन टेल यू एवरीथिंग. इट डिफाइंस एवरीथिंग इन केमिस्ट्री और इन एनी फिजिकल प्रोसेस, केमिकल प्रोसेस. व्हाट्स द गोल ऑफ एनी सिस्टम? टू अटेन द स्टेट ऑफ लोएस्ट एनर्जी. जनरली यही होता है, राइट? अब नाउ व्हाट इज दैट एनर्जी? दैट्स अ लिटिल कॉम्प्लिकेटेड. पोटेंशियल एनर्जी आप लोगों ने पढ़ा है. पोटेंशियल, यू नो, when you take water from क्या बोलते हैं उसको, waterfall, नीचे गिरता है तो उसकी potential energy कम हो जाती है, kinetic energy बढ़ जाती है. You have studied all this, right? Initially potential energy is maximum, kinetic energy is 0. At the bottom of the flyover बोल रहा है वाला at the bottom of the झरना, kinetic energy maximum and potential energy minimum. So this is what happens, right? Energy can be transformed from one form to another, but is neither created or destroyed. बहुत बेसिक फंडामेंटल आइडिया है. ठीक है, पोटेंशियल एनर्जी इज दैट सेम पोटेंशियल एनर्जी. द ओनली डिफरेंस इज नाउ इंस्टेड ऑफ दैट हाइट हम लोग चार्ज की बात करेंगे. ठीक है, आई नो दिस साउंड लाइक अ फिजिक्स सेशन, जस्ट बेयर विथ मी. सुपरपोजिशन, वाओ, दैट्स ग्रेट टू नो. कार्टी जी, कंग्रेचुलेशंस. श्योर ब्रो, अप टू यू. Yes, absolutely. MGH, yes, absolutely. You guys are so wonderful. Thanks for keeping the chat alive. Yeah, potential energy is a difference of potential into Q. ये potential क्या बला है? वो आप लोग देखते हैं ना, +5 volts, +12 volts. फोन चार्जर्स में होता है ना, फोन चार्जर 5 volts 1.2 एम्पियर पुराने वाले होते थे. आजकल तो ज़्यादा होता है ना, 5 volt 10 एम्पियर भी होते हैं. नहीं, 10 amp बहुत ज़्यादा हो गया. 10 amp तो like is scary. I don't think 10 amp makes any sense. Let's say 5 amp, even that would be pretty mad, right? 5 amp is also very high current, right? 25 watt का चार्जर जो होता है. 12 volts DC बैटरी होती है किस चीज़ की? नॉर्मली और चीज़ों की अप्लायंस होती है. दिस इज ऑन योर फोन, राइट? सो दिस volts आई एम टॉकिंग अबाउट इज दैट सेम पोटेंशियल डिफरेंस. ओके, ठीक है. आई नो यार, इसमें से कुछ डायरेक्टली समझने वाली चीज़ें थोड़ी मुश्किल हैं, बिकॉज वी हैवंट स्टडीड दिस इन डिटेल, एंड मैं बहुत ही सुपरफिशियली ये चीज़ें बता रहा हूँ ताकि आपको थोड़ा सा आइडिया लगे एंड यू आर एबल टू अप्रिशिएट व्हाट इज गोइंग ऑन, राइट? आई एम बीइंग ऑनेस्ट विथ यू, इन द स्टार्टिंग इट विल बी लाइक यार फॉर्मूला मग करना पड़ रहा है, But what I'm trying to do is trying to generate an interest so that it may not seem like we're mugging this randomly. Okay, so we figured out force between charges. Now we get into energy between, same setup, energy. Okay, energy होगी Q times V. Q मतलब charge, potential difference. ठीक है. What does this mean? If I have a large potential difference, the charge will fall or whatever. It has a holds more energy. It doesn't hold it, but transition जो भी है. ठीक है. Physics guy will teach you this better when they get to it. All right, ठीक है. And potential, by the way, is not necessarily just a plus and a minus. It could be a surface. What does it mean by potential of a surface? Surface में अगर जो है charges भरे पड़े हैं, तो it has some potential because कहीं और negative या फिर ground है. ठीक है, ये सब आपको physics वाले दोस्त पढ़ाएंगे. All right. So the main thing here comes from this idea, right? That energy is force into distance. Force was proportional to Q square. ये तो हमने हटा दिया ना, रुको, hold on. Force was proportional to Q square, Q1, Q2 by R square, right? We multiply that with distance का dimension. आप लोग units, tell me one thing. आप लोग units और dimensions कर चुके हो in physics. Maybe you have done units and dimensions, right? So from dimension analysis, I know that I have to multiply the dimension of R, and that's what we do, right? Distance, displacement, R, जो भी है. And potential energy becomes K, Q1, Q2 by R. This is important, is really important in fact. Okay, this is the first important thing from over here. Okay, potential, nahi Karti ji, I'm not in Chennai, I'm in Bangalore. Yeah. Potential of surface means swap, asking the right question. That's a difficult question for me to answer because I'm not a physics guy. But a surface, जैसे वो balloon था ना, you rub it, it gets a charge. So if it has some charge and there is a difference of charge somewhere else and it develops a potential. I'm just going to leave it at that right now. Swap. Potential of surface is a complicated thing. I should not have written that. Yeah, I should have just left it at potential. Surface makes it even more complicated, but that's a good question. I'll wait for physics guys to answer it when they teach this topic to you. Okay, so the potential energy at R point is proportional to the product of the charges divided by the distance between them. Okay. एक छोटी सी चीज आउट ऑफ द वे. हम लोग आज इलेक्ट्रोमैग्नेटिक वेव्स की नहीं बात करने वाले थे. क्या हम लोग चार्ज वार्ज की बात कर रहे हैं? अब देखो, इफ अ चार्ज इज मूविंग, व्हाट डज इट डू? आई नो there was a video that Veritasium released recently saying कि यार moving charges don't produce magnetic field. Let's keep that aside for a second. Okay, if you have not seen that video, great. If you have, keep that aside for a second. Let's stay within the realm of 11th and 12th chemistry and physics, and let's say that if there is a moving charge that constitutes a current flowing. This is fine. अगर charge move कर रहा है, that means a current is flowing. Why does the charge move? There is a difference of potential. Yeah, +5 0 or +5 -5 मतलब 10 volts का जो भी है, some potential difference there. Charge begins to flow. Okay, ठीक है, charge flow कर रहा है. Charge flow कर रहा है मतलब current है, और because there is a current, there is a magnetic field around it, which you will learn again. Is because इस direction से होता है and all of that, जो भी होता है, you will figure it out. So, whenever there are charges that are moving, there are magnetic fields associated with it. ज़्यादा हो रहा है क्या? Yeah, 11 students are watching. Great, Hitesh. Thank you for that update. Moving charges, yes, absolutely. Beautiful, beautiful. Swap. What the first equation says is energy. Okay, potential energy is K Q1 Q2 by R, and force is K Q1 Q2 by R square. Okay, these are two different things. Easy way to remember it is with dimension analysis, right? F into D is work or energy. Okay, potential energy का क्या होता है? ML2T minus 2, and this is MLT minus 2. ठीक है? This guy right here is energy and this is force. Have you studied? इसलिए मैंने पूछा, आप लोगों ने पढ़ा है dimension analysis? Please study dimension analysis properly. At least एक question जबरदस्ती आएगा आपके लिए physics में free में, yeah? And many questions maybe you will be able to figure out options with dimension analysis. मैंने जब AIEEE दिया था तब भी था, अभी JEE main NEET है तभी भी होगा, because things haven't changed. Whether it's a sad thing or a happy thing, but things haven't changed. So I'm confident that this will help you. Yeah. Swap. R square तक R तक कैसे आए? Force into distance is energy. Okay, that's how we are going there. All right, sweet. So moving charges are current, and let's take a hop, skip and a jump and say कि moving charges की वजह से current होता है और current की वजह से magnetic field भी होता है. And interestingly, another leap of faith, both of these are waves. Okay, current can be represented by a wave. This will make a lot more sense to you 1 year down the line. ठीक है, अभी I'm the bad guy because I'm the person, the chemistry guy has to teach you this. So I'm going to be the bad guy. like भाई क्या पढ़ा रहा है ये? हाँ, क्या करें? जो मैं आपको 1 घंटे में बता रहा हूँ, that will be taught you by physics guys in 12 or 15 hours. ठीक है, so bear with me over here. Current is a wave. Magnetic stuff also is a wave. The main difference is कि they behave. What is a wave? थोड़ा waves की बात कर लें. Okay, let's talk about what is a wave in the first place. Yeah, let's talk about what is a wave in the first place. Electromagnetic wave. They're together. Wherever there's electricity, there's also magnetism. Let's keep it at that. Yeah, let's keep it at that. So there is this idea that they oscillate perpendicular to each other. What does this mean? What is oscillation? See, when a wave exists, okay, you studied waves in 10th grade. Yeah, all right, alpha beta, absolutely, thanks for that. But AIPM, मैंने AI triple E बोला था. Maybe you heard as AIPMT. I gave AI triple E. That was precursor to JEE main. Yeah, all right. So भाई देखो, टाइम पास क्यों करना है? पढ़ाई करना है तो कर ले, काम नहीं तेरे पास लाइफ में. Hold on, yeah, I have to do this. All right, cool. So yeah, what is PWOP? I don't know, I have no idea what that's. Is that like a physics term that I don't understand? Anyway, you'll have to tell me what that is. So you've got waves, right? What is a wave anyway? Anyone wants to tell me what do you know about waves from 10th grade? Have you studied waves at all in 10th grade in physics? The main idea is that there are some particles that oscillate, okay, and because of that particle oscillating, it looks like the wave is moving forward. The best example wave का इसमें क्या होता है? Take a stone and throw it into water, right? And once you do that, you will see ripples being formed, right? पानी move हो रहा है, but पानी move नहीं हो रहा है, right? पानी move ऊपर नीचे कर रहा है particles के, like the water starts bobbing up and down, but you see ripples moving outwards, right? So what this is saying is that particles are moving physically up and down, but the wave, whatever wave is, it's moving out. So in a way, that is energy moving outwards, which dissipates with time. Now that's a realistic situation. We are not going to study about energies that dissipates with time. Okay? We're not talking about that at all. But this is a simplistic way, सबसे आसान तरीका of understanding what a wave is. ठीक है, wave को समझने का सबसे simple तरीका ये है. Oops, hold on, I made it full screen. I should not have done that. Now I can't see anything. Please bear with me. All right, we have sorted this out. New setup. Yeah, still figuring things out. Thanks for being patient. Okay, cool. ठीक है, तो wave मतलब there are particles पानी के oscillating up and down, but it looks like the wave is traveling outwards. Okay, so there is some traveling of the wave, some information being transferred. I know I'm using a lot of new terms. Okay, ठीक है. These are the oscillations we are talking about. Okay. Now the next leap of faith is there are no particles. In electromagnetic wave, there are no particles. Something is oscillating. ठीक है. There is a direction of propagation of the wave. Say that the wave is moving इस तरीके से, ठीक है, from there to here. This is the direction of propagation of wave. Again, this will be clear to you when your physics friends teach you. In fact, you are able to hear me. My voice is sound, it's a wave. But you are able to hear me because electronics between me and you are translating it, doing all this. So between you and me, all this is going on. Exactly, this is going on. There is an electric field. मैं जो बोल रहा हूँ माइक में जा रहा है, माइक से इलेक्ट्रिक सिग्नल बन के कंप्यूटर पे जा रहा है, which understands कि कुछ मैं बोल रहा था, that's converted into packets through the internet, comes to you. This is exactly this, okay? Whether you like it or not, this is exactly what this is. ठीक है, कुछ waves हैं जो जा रही हैं, and these are perpendicular to each other, electric field and magnetic field. Oh my God, this is the craziest part. They don't need any medium for propagation. Light जो आपके पास आती है from the sun all the way to you is an electromagnetic wave. Okay, that's what we're trying to say. It does not require any medium for propagation. I know we have hop, skipped and jumped a lot of concepts. मैंने पहले बोला, let me recap everything I've said till now. There's something called waves, which you understand by the whole ripple वाला effect. But वहाँ particles oscillate ऊपर नीचे कर रहे थे, but energy was moving outwards. Okay, that was one idea. Here there are no particles, but still energy is being moved. How? Because current flow कर रहा है और current के साथ electromagnetic waves जा रही हैं, जिसमें magnetism वाले जो magnetic waves हैं, they are perpendicular to the electric waves. There are 3 dimensions, right? If you have this dimension में, say right here, let's go back to the diagram very quickly. Yeah, in this axis, yeah, in this plane you've got say electric field, In this plane you've got the magnetic field, and between both of them you've got this nice information being transferred. What information? My voice and video and everything else. Okay, they can travel in vacuum. Okay, that was pretty hard, huh? That was pretty hard to follow. What is electromagnetic wave? Thanks Shinoy, great question. पिछले 10 मिनट से हम लोग यही बात कर रहे हैं. रामायण एंड राम कौन है? हाँ, that's great. All right, swap, that's lovely. Okay, thanks for that input. Yeah, yes, नसरत बिल्कुल सही. Alternate crest and trough. अरे वाह नीलांजन मित्रा, जियो मेरे लाल. You're talking about exactly what I'm going to talk next. Lovely. Yeah. Alpha Beta is asking a question. I can't see the whole question. Let me go and check it out. 1 second. Why are electric field and magnetic field propagation perpendicular to each other? Why is a tough question. They are, that has been, what do you call it, observed. With nature, there are some things you observe and there are some things that you hypothesize, right? तो मैंने ऑब्जर्वेशन देखी और उसके ऊपर मैं कुछ हाइपोथेसिस बना सकता हूँ. दैट्स व्हाट वी आर डूइंग एट माय लेवल. मे बी देयर आर मोर रीजंस एज टू व्हाई दे आर परपेंडिकुलर टू ईच अदर, बट या what I know is ki you observe this and then you manipulate it to do funky things with it. Yeah. Nilanjan, okay. Yeah, we're not going to talk about that at all today. Yeah, but if you wanted to learn more about it, ping me here and I'll give you stuff to read on it. Okay, it's there in Atkins and you can read up more on this. The machines that can measure all those effects are there at IISc in Bangalore. You can check those out if you are in Bangalore at any point in time. Okay. Let's stay on track. And you ask amazing question. What is alpha beta? It's the name of the guy. I'm talking to the guy over here who asked me what is the reason and all of that. Yeah, interestingly, they all travel at the speed of light. If they all travel at the speed of light, what makes them different? Speed of light. Light मतलब वही same light जो मुझे दिख रही है, मतलब ये purple color, ये color. This is a small part of light. Yeah, all of this is things I can see. तो इसको हम लोग visible बोलते हैं. ठीक है? There is a broad spectrum of electromagnetic waves. I use the word spectrum. ये spectrum क्या बला चीज़ है? Spectrum तो एक coaching institute हुआ करता था. I'm kidding, partially. I think I've heard of a coaching institute called Spectrum. Free publicity for them. Anyway, so you saw something interesting happening there, right? All waves have some wavelength, some frequency, and some velocity. We'll talk about that. Okay. They also have time period and something called wave number and amplitude. These are things used to define a wave. जैसे आपका नाम से अल्फा बीटा है. You were born in the year 2008 or something, I don't know, and you are from place X and whatever, you know, this is your address, so you need some things to define you. I know these things don't define you. You are much more than where you were born and all of that, and not get into the philosophical debate. But electromagnetic waves need these things to define them completely. The wavelength, the frequency, and both of these give you the velocity. From the wavelength and frequency, you can derive time period and wave number. What are these things? हम लोग with the course of these lectures figure out करेंगे. Okay, so this is the simplest form of a wave. Yeah. What is vacuum? Vacuum मतलब जहाँ कोई pressure ना हो, जहाँ कोई particles नहीं हो. That's a lovely question, Shenoy. You guys ask wonderful questions. What is vacuum? Vacuum वो होता है जहाँ कोई particles ना हो. अभी आप लोग को बहुत लोग बोलेंगे वैक्यूम मतलब वेयर प्रेशर इज जीरो, बट प्रेशर इज जीरो का मतलब क्या है? व्हाट इज दिस प्रेशर इक्वल टू जीरो? एंड यू आस्क समबडी व्हाट इज वैक्यूम, दे से प्रेशर इज जीरो, बट द रियल रीजन इज प्रेशर, दैट इज द इफेक्ट. व्हाट इज द कॉज? कॉज है वैक्यूम में देयर आर नो पार्टिकल्स, देयर इज नथिंग, कुछ नहीं है, स्पेस, राइट? सो if there's any physical particles of air or something, कुछ ना कुछ pressure होगा, because they will bounce across and all of that. You learn this later on. Okay, pressure का origin is theoretically because particles bounce off against the walls of a container. ठीक है, that's pressure. What is vacuum? No particles, no pressure. That is vacuum. Okay, ठीक है. Great question. Whimsy. All right. Thanks for that. Let's continue. Yeah. Characteristics of electromagnetic waves. What are the characteristics? जो हम लोग ऊपर देख रहे थे. ठीक है. This is a wave now. I've got a couple of axes. To understand this better, I'm going to call this graphs का आपको थोड़ा बहुत idea होगा, right? This is the x-axis, y-axis. On the x-axis, I am figuring out कि this is the direction in which this is traveling, right? Direction. Let's say it goes from left to right. Okay. What is ऊपर नीचे? This is the oscillation. Oscillation का क्या मतलब है? आपने पेंडुलम देखा होगा ना, वो क्लॉक में, ग्रैंडफादर क्लॉक में something that goes like this, ding dong ding. No, it doesn't make any noise. But you know, Big Ben or whatever. No, I don't think Big Ben has pendulum. Oscillation मालूम ना? It's not that hard. Figure out oscillation. It goes to and fro from a mean position. What is the mean position? This is the mean position. ऊपर, नीचे, आगे, पीछे, round and round. ठीक है? This is oscillation. Okay, and this is the direction in which it goes. Now, wave का properties: crest ऊपर वाला part, trough नीचे वाला part, एंड कितना ऑसिलेट करता है, दैट इज कॉल्ड एम्पलीट्यूड. फ्रॉम द मीन पोजिशन, द डिस्प्लेसमेंट, you know all of this, from mean position is known as amplitude. Okay, great. All right, sweet. Now with this I can calculate couple of very interesting things. The distance between two crests or two troughs, this is the wavelength. If this is the wavelength, if this is the direction of this thing. Okay, so what am I doing? How did I draw this graph? एक बात बताओ. How did I draw this graph? What is the meaning of this? एक ग्राफ मैंने कुछ बना दिया, कैसे किया? So say a wave was moving like that. पानी में मैंने वो फेंका ना. We can draw parallels. It's the same thing. I take a stone and put it in water. Then some energy keeps moving out. So I take a photo in time, like click. Okay, I've clicked it in time. So it at a particular time. At time t, एक पर्टिकुलर टाइम पे मैंने किया और मुझे ये स्नैपशॉट दिखी एग्जैक्टली लाइक दिस. देन आई कैन मेजर डिस्टेंस बिटवीन टू ट्रफ्स. ये हो गया वेवलेंथ. समझ में आया? ठीक है, कूल, वी गुड. दिस इज वेरी इंपॉर्टेंट व्हाट आई एम सेइंग राइट नाउ. इट्स ओके गाइज, लेट्स फोकस ऑन टुडेज सेशन. आप लोग को टाइम पास करना है. यू हैव अ लॉट ऑफ प्लेसेस टू डू टाइम पास. हियर लेट्स फोकस ऑन व्हाट आई एम सेइंग, और एटलीस्ट लेट्स फोकस ऑन एटॉमिक स्ट्रक्चर यार. ठीक है, बाकी हम लोग बाद की बातें करते रहेंगे. लेट्स टेक अ क्विक क्वेश्चन ऑन दिस. ठीक है, हियर इज द क्वेश्चन. आई हैव जस्ट टोल्ड यू समथिंग. लेट्स सी अगर आप लोग सुन रहे थे नहीं सुन रहे थे. इफ अ स्नैपशॉट इन टाइम इज टेकन ऑफ अ वेव, देन वी कैन मेजर इट्स फ्रीक्वेंसी, वेवलेंथ, एम्पलीट्यूड. व्हिच ऑफ दीज थ्री कैन यू मेजर? ऑल ऑफ देम, all four of them? I'm going to have to put you on a timeout, guys. If you guys are going to bicker, focus, be mature, use this cosine graph. Lovely. Okay, all right, nice. Okay, let's go. Yeah, guys, come on, focus on this. What is atomic structure? Shenoy, I feel like you're just doing time pass now, but okay, cool. Let's go. Can we talk about this question, please? All right. For the interest of the other students here, I'm going to have to do this. All right. Snapshot means what? Snapshot means photo. Like click. I took a photo. Click. Snapshot. Whatever you're doing, in the middle of your action, you take a photo. That's a snapshot. Okay. D. 1, 2, and 3. Okay. A lot of you are saying D. Okay. Let's see. Can you think a little bit through this? What is frequency? Frequency has to do with time. मैंने आपको बताया नहीं है frequency क्या होती है, but आप जानते हो ना. What is the frequency of drinking water in a day? I think I should drink around 10 glasses. No, you should drink 16 glasses. हाँ ठीक है, जितने भी ग्लास पीने हैं पी लो, but you will drink some glasses. That's the frequency of drinking glass in a day, right? So you understand, frequency has something to do with time. There's a time factor here. What that factor is, we'll get to it. But कुछ factor है time का, something has to do with time. But yaar, when I take a snapshot in time, then I have fixed time. How can I get frequency from that? I cannot get frequency from this. See, look at this. If I am plotting on this graph, I have plotted amplitude versus distance. Plot kaise kiya bhai? I have taken snapshot. Click. Wave is moving. I have said statue and I have noted down the distance of everything. Like, okay, it's moving like this. Cool. From this, I can get wavelength. Cool. So not D. It's okay. It's all right. Don't worry agar sab log D keh rahe hain. It's not a problem at all. Right? Since it's the first time I'm teaching this, I don't expect you to know this. But after this, I hope you understand what this means. Okay? There are two unknowns over here. Speed kya hoti hai? Speed is frequency into wavelength. This is the definition. I know we haven't done this, but this is the definition. So there are two variables. I don't know both of them. How will I get this? So I can only get wavelength by measuring distance between this thing, and amplitude to simple. Okay, let's take another question. This will be much clearer. Okay, so answer of this is not going to be D. Sorry, it's going to be frequency and wavelength and amplitude. 2 and 3 only. Yeah, B. Erase all ink on slide. This is the answer to this one. Next question. This one's interesting. Okay, no problem. Don't worry about it. Whimsy, Nasrat, student, Alpha, Beta, and Mai. Thank you so much for the answers. The important thing is you participate. Don't worry if you get it right or wrong. This is a learning experience. Yeah. When we plot the movement of a particle with displacement from the mean position on the y-axis and time on the x-axis, then we can measure its what? अब ध्यान से देखो, मैं बोल रहा हूँ mean position on the y-axis. Mean position का क्या मतलब होता है देखते हैं. इधर we are doing time now. What is mean position? Tell me, please think about this. No, student, how? We'll think, socho. Let's do this question. You'll understand. ये वाला question करो, then you'll understand. You can't. You need the speed. Without the speed, you cannot do it, student. Okay? Condition should be at least 180 degree determinate wavelength. Okay? Cool. Thanks. Yeah. बिल्कुल सही बोला आपने. Let's do some very basic stuff, then we'll do more complicated things. ठीक है? Let's do this. ये बहुत straight forward चीज़ है. मैं बोल रहा हूँ कि यहाँ पे टाइम हम लोग जा रहे हैं, and here we're doing amplitude. Amplitude means what? Mean position मतलब, अरे मैंने आंसर ही बता दिया. Displacement from mean position. This is mean position, displacement. Now this is weird. The graph looks exactly the same, boss. But the things you can measure are going to be different. This is amplitude plus A minus A. But the things you can measure are going to be different. Yes, swap, exactly. We mean that. We mean exactly that, swap. I feel कि आप कुछ पढ़ के आए हो इसलिए आप ये बोल रहे हो. We are not doing Heisenberg uncertainty all that. We haven't got to that. Screen black आ रहा है. Arnav ji, maybe screen black आ रहा है? I don't think so. I have the preview over here. It seems okay to me. Maybe it is an issue with ad blockers. If you're using some weird script blockers or something, कभी-कभी ये सब चीजें होती है. Please check it out. क्या करें यहाँ पे? अब देखो, now that I've drawn this graph for you, what can you calculate for sure? I haven't told you what frequency, but I've told you. I have also told you and not told you. What is frequency? The number of times you do something in a day. Okay. पानी पीने की frequency है 16 glass. 16 glasses per day of water. That is the frequency of drinking water. So you see, time की unit हो गई denominator में. You understand this? And that is what frequency is. Frequency is the number of times this guy goes through this in 1 second. So if I do time on this axis, already ऊपर लिखा है, sorry. Time है इस axis पे. So if I measure this between these things, this is the time period. ठीक है? Capital T, also known as time period. So I know that between two troughs, it takes this much time. So that's the time period. What is frequency? It is 1 by time period. Okay, that's the definition. You will never forget it now. Frequency is 1 by time period. Time period क्या है? In the graph of amplitude versus time. In the graph of amplitude versus time, the distance between two troughs or two crests. What are we plotting? Amplitude versus time. Here I can calculate frequency and amplitude. Similarly, the graph looks the same, okay? It looks the same, but what I'm plotting is difference over here. This is a snapshot. Let me use a different color ताकि आप लोग confused ना हो. Let's say snapshot. मतलब मैंने फोटो ले ली. अगर मैंने फोटो ले ली तो टाइम तो है ही नहीं यहाँ पे. तो यहाँ पे है distance of the wave traveled. Yeah? Distance traveled by wave. And this is amplitude. These are two different things. Distance traveled by what? By wave. ठीक है? Not by the particles. ये है wave का movement. Okay? Wave का movement. Literally like this, you know, लहरें move करती है, right? That is that. Particles का oscillation is up and down. Up and down. Okay? A plus A minus A is this. Are we good now? Yeah? Do you understand now? Swap, Alpha, Mai, Whimsy, Nasrat, everybody else who's lurking. Do you guys understand this? The two difference between these two waves, these two ways of. So these are two ways of for me to showcase the information about the same wave. Same wave की हम लोग बात कर रहे हैं. But it's a 3-dimensional thing. You get it now, right? अगर 3 dimension है तो तुमको 2 dimensional ग्राफ में बनाने के लिए एक चीज को कांस्टेंट रखना पड़ेगा. That is what I'm trying to say. Got it? 3 dimensional चीज, टाइम भी चीज है. मैं उसको 2D में करने के लिए, this is a 2D graph. How do I represent it? I say कि let's keep time constant or let's keep this distance thing constant. Time बदलता रहता है. ठीक है? That's what we do here. Which is why you can only measure both of these things. Very cool question, right? So what are we measuring here? I can measure frequency and I can measure amplitude, not the wavelength. So 1 and 3 only is the answer to this one. Whew. So what are the characteristics of an electromagnetic wave? Oh, Barish Shuru. How is it there? Is it raining where you are at? What are the characteristics of an electromagnetic wave? Its wavelength, the distance between two consecutive terrestrial trough, and SI unit is M. Frequency क्या होती है? Number of waves passing at a given point in 1 second. 1 second में कितनी waves जाती हैं? SI units है hertz और per second. Frequency is going to be 1 by time period and ये related है time period like this. And time period कैसे निकालोगे? In the graph of amplitude versus time, उस graph से आप time period निकाल सकते हो. And in the graph of what are we doing here? Amplitude, एक और पीछे जाते हैं. एम्पलीट्यूड वर्सेस डिस्टेंस ट्रैवल्ड बाय वेव, इस ग्राफ से आप लोग वेवलेंथ निकाल सकते हो। ये सब आपको कोई नहीं पूछेगा जेई में कहीं पे भी, बट इट विल हेल्प यू इन फिजिक्स फॉर श्योर। ओके, बट लेट्स सेट दीज ग्राउंड रूल्स टू अंडरस्टैंड ऑल ऑफ दिस। ऑल राइट, वेलोसिटी क्या होती है? वेलोसिटी इज वी और सी। कोई बोल रहा था ना कि अगर वेवलेंथ हो तो आप लोग जो है फ्रीक्वेंसी निकाल सकते हो। दैट इज ट्रू ओनली फॉर इलेक्ट्रोमैग्नेटिक वेव्स, नॉट जनरली एनी वेव्स। उसके लिए क्यों निकाल सकते हो? बिकॉज यू नो दैट वेलोसिटी इज इक्वल टू स्पीड ऑफ लाइट। यू नो दैट, इसीलिए आप निकाल सकते हो। समझ रहे हो? somebody asked me that early on also। मैं जनरली वेव की बात कर रहा था उधर। ओके, ब्यूटिफुल। सो what does that bring me to? The most important thing so far, which is the speed of light c is equal to lambda times nu, which some of you already have heard of, and hence you are talking about this. Okay, good job, good job. Time period का तो बता ही दिया मैंने आप लोग को। इसका time taken to complete one oscillation, and the unit is s. The last idea, which is wave number, is a fascinating and weird thing, right? Which is known as number of waves per unit length. Now this is such a random thing, yeah. अल्फा मैंने बोला तो थिंक अबाउट इट लाइक दिस, नो। लॉजिकल एक्सप्लेनेशन ये है, फ्रीक्वेंसी ऑफ ड्रिंकिंग वाटर, ऑफ हाउ मेनी ग्लासेस ऑफ वाटर डू यू ड्रिंक इन अ डे? यू प्रॉब्ली डोंट ड्रिंक 16 ग्लासेस, इसलिए तुमको अजीब लग रहा है। 16 ग्लासेस पर डे, दैट्स द फ्रीक्वेंसी। व्हाट इज दिस? दैट यू, दिस इज टाइम, दैट इज इट। हेंस दिस इज द यूनिट ऑफ फ्रीक्वेंसी इज 1 बाय टाइम। दैट इज व्हाट आई एम सेइंग। नो, अब ये ग्लासेस में पी रहा हूं पानी का, इसके बजाय वी आर टॉकिंग अबाउट फ्रीक्वेंसी ऑफ अ वेव, राइट, where does not have any particles, it's just oscillating, is chilling out, तो उसकी frequency में there is no numerator, right? This 16 glasses does not make sense there. Okay, that's the logic behind frequency being 1 by t का logical thing. Cool. You look at it from the point of view of units and dimensions and you'll understand it. Okay, wave number is a little weird, right? Number of waves per unit length, and this sounds a little strange. We'll talk about this when we do some interesting derivations later on. ठीक है? From now, as of now, just take it as statement of fact. Okay, to summarize, this is what we have so far. Okay, these three things. Any doubts? Any doubts? Please ask me if you have any doubts, and we'll move on to the next interesting part of this topic, which is light as a wave. Okay, how does light behave as a wave? That's the next thing we're going to talk about. कोई doubts है? Anything you want to talk about here? Are we good? Shall we move on? Please let me know in the chat. Yeah. Is this very very complicated, or are you able to figure things out? अभी कैसा लग रहा है इसमें? बताओ मुझे please. Give me like an idea here. How's it going? How's it going so far? Just like some feedback would be good. Just going to get a bit of water. Oh, पानी में लाया नहीं. Okay, all right, cool, great. Let's go on. Let's go on. By the way, a small question. I have not taught this to you, but do you know this? Do you know this? Yeah. What about the second question swap? कौन सा second question? Where I was telling you कि time period of वो वाला चीज. What about that? Give me details. Do you know this? The volume of nucleus is about how small is it as compared to that of an atom? 10 power minus 4 times, 10 power minus 15 times, 10 power minus 5 times, 10 power minus 20 times. Nucleus और atom के बीच में फर्क क्या है? I know you've seen this picture a lot of times, right? There's nucleus and then there is some weird thing around it, or you have seen these kind of, okay, I'm bad at diagrams, shouldn't draw them. इसलिए मैंने बायो नहीं ली लाइफ में. It was very bad diagrams. So you've seen some stuff like this, right? इस टाइप की चीजें देखी हैं. I've seen this. So that thing in the center is supposed to be the nucleus, right? B, all right. Okay, cool. All right, sweet. Cool. Let's move on to the next idea. Swap, you still haven't told me what is it that your doubt was? Yeah? Okay. Let's talk about this electromagnetic spectrum. हम लोग बोल रहे थे कि waves के बारे में, राइट? वी आर टॉकिंग अबाउट विजिबल स्पेक्ट्रम, लाइट, करंट, वो सब चीजें. हमने करंट और मैग्नेटिज्म की बात की. नाउ वी आर डूइंग अ लिटिल बिट मोर कॉम्प्लिकेटेड स्टफ. ओके, व्हाट यू सी अराउंड यू, एवरीथिंग इज पॉसिबल बिकॉज लाइट एट द विजिबल फ्रीक्वेंसी इज हिटिंग योर आईज. ओके, वापस कहीं से बाउंस होकर आ रही है, मेरी आंख में जा रही है, रेटिना में इमेज फॉर्म हो रहा है, ऑल ऑफ दैट, सो आई एम एबल टू सी इट. ओके, बट देयर आर मेनी अदर थिंग्स दैट्स नॉट विजिबल. ओके, and what makes things different? If all the electromagnetic spectrum is traveling at speed of light, what's differentiating them? Their wavelength. Okay, their wavelength and their frequency. So microwave, जिसमें आप पानी गर्म करते हैं या फिर खाना बनाते हैं, that has a wavelength of approximately 1 centimeter. वो मुझे मालूम है. क्यों मालूम है? Why do I know this? Because you see that mesh microwave में एक mesh होती है, right? It looks like this. There's some mesh there. अगर आपके घर में माइक्रोवेव है, पास में जाके देखो, ये mesh का डिस्टेंस अप्रोक्सीमेटली 1 सेंटीमीटर. ताकि जो है आई थिंक इट्स मे बी लार्जर एक्चुअली, नॉट 1 सेंटीमीटर, मे बी अराउंड 10 सेंटीमीटर और अबाउट 1 मीटर, शायद मुझे याद नहीं आ रहा है, कैलकुलेट करके देख लेना. सो बेसिकली नो इट डजंट मेक सेंस टू बी 1 लीड, इट मस्ट बी अराउंड 5-10 centimeters. So the wavelength is larger than these things, and I'm not kidding. Okay, that's why there's a 5-second beep 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 beep, 4 बार बीप होता है ताकि आप उसको गलती से खोल ना दे और माइक्रोवेव बाहर ना जाए. आई एम नॉट मेसिंग विथ यू, दे डू हैव सम सॉर्ट ऑफ फेल सेफ एंड ऑल ऑफ दिस, बट बी केयरफुल. ओके, वो उसको बीप बीप करने दो ताकि अंदर के माइक्रोवेव वहां जाके डिस्ट्रॉय के खत्म हो जाए. या 407 nanometers. ओके, ऑलराइट कूल. भाई कॉमर्स में भी बहुत मैथ्स होता है अल्फा जी. खैर, गामा रेज आर द स्कैरी वंस, दीज आर द स्कैरी वंस. ओके, दीज आर वेरी हाई फ्रीक्वेंसी एंड हेंस दे आर स्कैरी. सो फ्रीक्वेंसी से स्कैरी हो गया. अच्छा, कीप दिस इन माइंड. ओके, हाई फ्रीक्वेंसी मीन्स हाई एनर्जी. कीप दिस इन माइंड दोस्तों, प्लीज पे अटेंशन टू व्हाट आई एम सेइंग. यू नो दिस फ्रॉम अ फैक्ट. इफ यू हैव डन एनीथिंग ऑन एनीथिंग, कभी पढ़ी न्यूक्लियर पावर के बारे में, गामा रेज आर रियली स्कैरी. X-ray is also pretty scary. You're not supposed to get X-rays without some sort of protection. And हाँ, microwave आप घर में तो यूज करते हैं, तो daily use it, so it must not be that scary. Radio waves are also okay. Radio waves is what, you know, जो भी आप phone communication होता है वो सब all that's radio waves, so that's chill. But gamma rays, they are bad, high energy, very very scary stuff. Okay, so this is the whole spectrum, electromagnetic spectrum. This is what it looks like. बदल जा भाई. Okay, visible light बहुत छोटा part है. You see there is a huge spectrum. Okay, high wavelength radio waves and microwaves, and then you go all the way to the end. You've got gamma rays and all of that. ठीक है, cool. Microwave oven, light energy to heat energy. Actually, swap. There's something crazy happens here. Hi Neetu. What happens in microwaves is something crazy, right? Microwaves में पानी जो है ना वो उबलने लगता है. Literally, it is crazy. पानी के अंदर there is some crazy chemistry happening. Chemistry, physics जो भी बोलना चाहो, जिसमें हाइड्रोजन जो है उसका स्टार्ट ऑसिलेटिंग एंड उसकी वजह से गर्म हो जाता है. ठीक है, विल टॉक अबाउट दैट इन फिजिक्स थोड़ा, सॉरी इन विल टॉक अबाउट इट इन थर्मोडायनेमिक्स कि ये क्यों होता है. आई विल टॉक अबाउट माइक्रोवेव अगेन इन थर्मोडायनेमिक्स. विल, सो इफ यू हैव इनफ पेशेंस, वेट फॉर अ फ्यू मंथ्स एंड विल टॉक अबाउट दैट. ऑलराइट, नाउ लेट्स टॉक अबाउट दिस. मैंने अभी ये बताया बहुत कॉन्फिडेंटली कि यहाँ पे है भाई वेव, तो मतलब डज दिस मीन दैट लाइट इज अ वेव? बिकॉज लुक्स लाइक it has some wavelength, it has some frequency, so does that mean that light is a wave? It looks like it. But why this wave nature of light explains something called diffraction, something called interference. What these things are बाद में पढ़ेंगे, ठीक है, but they explain some of these. They don't explain all of these things. They don't explain them at all. They don't explain these things. Out of these, maybe right in the next session we will encounter photoelectrified. आज के बारे में हम लोग कितना टाइम बाकी है? We have some time. थोड़ा लंबा this session may go on to a little bit longer than 1 hour. I'm just going to go and get some water. Why don't you go online and look up what is black body radiation? लिट्टी जी, NCERT करिए, मॉड्यूल तो आप करते रहेंगे. डाउनलोड दी ऐप, दी आकाश ऐप, द बाइजूस ऐप, डाउनलोड करिए, सॉल्व क्वेश्चंस देयर, रीड NCERT, यू आर सॉर्टेड. What is the source of energy in electromagnetic waves? The sun. Swap. The source of the energy is Surya Dev. The sun, literally nuclear explosion happening in the sun, वहां से आता है energy and it's able to send energy all the way from there to here, 93 million miles away, जितना भी दूर ही है वहां से आता है. Okay, so I'm going to fetch some water कुएं से. In that about 1 minute or so that I go and get water, please try and read what you can from Wikipedia, from anywhere. What on earth is this black body radiation? थोड़ा पढ़ो, मैं भी आता हूँ, पानी लाना भूल गया. भाई जो भी करते हो लीगली करो यार. That's my only suggestion. No talk of piracy will be tolerated here. I'll be right back. Give me a minute. And I am back. What's up? What did I miss? You studied Aakash offline? That's great, Litti. Isn't Litti like Litti Chokha, वो जो आलू और दाल बाटी जैसी वाली चीज़ होती है? That's cool, man. Did anybody read up on what is black body radiation? We'll talk about it. ये स्पेक्ट्रम के बारे में हम लोग थोड़ी बात करते हैं पहले. या बिफोर वी गो टू व्हाट इज ब्लैक बॉडी रेडिएशन, लेट्स टॉक अबाउट नॉर्मल बॉडी का रेडिएशन क्या होता है. नॉर्मल, कहां से लाइट आती, कहां से. लेट्स टॉक अबाउट दैट. Yeah, swap, that's a great question. I told you that in the starting, but maybe you missed the connection, right? मैंने शुरुआत बोला था, but maybe you were not there back then. As a reminder to everybody who's still here, what's the point of all of this in atomic structure? Okay, what's the point of all of this in atomic structure? We are trying to establish that light can behave as both as a matter and a particle. Okay, as matter and particle, which is crazy, it's mind blowing. Then we'll go and say कि जो subatomic particles हैं, like electrons and protons, they also can behave like a particle and a wave swap. That's the point of this. Let me write that down for anybody questioning this. There's some slides here talking about white light through a slit. We'll talk about that. Okay, so light, the point of this session is as a wave. Next में हम लोग बात करेंगे कि as a particle, and then we'll say कि subatomic particles like say electrons, protons, they can behave as particles and as waves, and that will lead us to figure out some crazy things about the structure of the atom. ठीक है? Thanks for asking that question. Although I did answer it in the starting, but ठीक है, एक बार फिर से. Okay, so to understand this black body radiation thing, जो नहीं explain कर पाया, yeah, we are getting to this part now, light as a wave and a particle. We're getting to this light as a particle. हम लोग light as a wave kind of discuss कर ही चुके हैं, right? Electromagnetic waves, बोला frequency, wavelength, हमने spectrum की बात की. But spectrum होती क्या भला है? Like how do you see it? Can you see it at home? Yeah, you can. Just get this thing. Just get a prism. You can buy a prism. Maybe you have one in school. Yeah, it looks like a triangle, but it's actually a prism. Okay, it has depth. May not seem like it. ठीक है? This is a prism. ठीक है? Get a prism. You've seen that Pink Floyd album cover, right? Light जाती है and then it splits up into rainbow colors like this. Yeah, the Pink Floyd album cover. Which one was it? Was it something to do with the wall? It was the wall, wasn't it? Anyway, so you get a wall over here on the other side and you're able to see these colors. Okay, so white light splits into Vibgyor. Yeah, a band of colors, exactly, all of the colors. Yeah, all the colors in the rainbow, right? Prism यही करता है. ये आपने पढ़ा होगा 10th में. Have you studied this in 10th? Or maybe you studied it in 11th in physics. Either way, it breaks down into the colors of a rainbow. ठीक है? And you'll see Vibgyor, if you want me to write down. Vibgyor. I know I don't have enough space, but भावनाओं को समझो. उल्टे डायरेक्शन में आता है, ठीक है? Oh, by the way, if you have not already inject, ये चीज़ अगर अभी नहीं समझ में आई है, frequency of this is the highest, इसकी frequency है lowest. ठीक है? Interestingly, सबसे ज़्यादा bend वही होता है जिसकी frequency सबसे ज़्यादा है. These are things I'm already telling you without telling you. ठीक है? It's a drawing में, diagram में, all this is hidden. Anyway, so this is the visible spectrum of light. ठीक है? Okay, welcome Ashutosh. Thank you for joining up. Yeah, stay strong. Okay, so this is a visible spectrum, and this looks like a continuous spectrum. ऐसा लगता है रेनबो जो आपने देखा हुआ, लगता है ना क्या, कितना ब्यूटीफुल चीज है, बिल्कुल कंटिन्यूस लग रहा है, बट एक्चुअली इट्स सीम्स कंटिन्यूस, but it's made up of a lot of tiny things that you can't see. Yeah. Oof. What does this mean? Continuous का opposite क्या हुआ? Discrete. We started with that. Remember? We said quanta of charge. Quanta of charge मतलब charge was quantized, मतलब charge के steps थे. If you've been here from the starting, steps थे. That's the opposite of continuous. Continuous होता है ये. This is continuous. Like a slope. वो होता है ना कि बूढ़े लोगों को चलने के लिए slope देते हैं. Or if they're indifferently able people, they can use a wheelchair. That's a slope. That's continuous. This is not continuous. It's discrete. Okay. Now, this is something interesting. This is a basic thing जो आपको maybe 9th 10th से already मालूम थी. Now let's get into 11th grade stuff. Okay. What am I doing? I've taken light. I'm passing it through a lens to focus it. And then I'm passing it through this. So now what I get is this weird band that looks like this. It's a literal band. It's like this rectangular thing that you get. This is exactly what happens. This is the experiment you will be doing in labs. I hope if you get access to a lab, this is what you'll be doing. Discontinuous. What does it exactly mean in matter? That's a great question. To our eyes, it means nothing. student Ash. It means nothing to our eyes, but at the microscopic level, it means the world. It means literally the world. The fact that things happen in different packets and not continuous, it changes everything. Okay, that's great, Aya. That's great to hear. I hope your experience is good. If it's not, well, give us feedback, I guess. All right. So this is what it actually looks like. Same चीज तो पहले ही थी, बस मैं उसको थोड़ा सा साइंटिफिक कर रहा हूँ. ठीक है. You get a slit, उसको जो है थोड़ा हम लोग अलाइन करते हैं व्हाइट लाइट को, and we'll put it through a lens. We'll make sure कि एक ही पॉइंट पे जा रहा है. Then it gives you wonderful band of colors. Okay. Now something crazy happens after this. This is light. Normal मतलब हवा में. हवा मतलब I've got oxygen, nitrogen, हजारों चीजें हवा में. ठीक है, व्हाइट लाइट कर रहा हूँ. Now, what do I do? Okay, interesting, right? अब हम लोग क्या करें? Now, I'm going to say that you take some amount of light and you take just one gas. Say you take hydrogen and you pass light through it. What do you think is going to happen? कोई एक particular gas लो. Do you have any idea about this? Have you heard of this sort of thing? A random gas and pass light through that gas? Will it matter? आपको क्या लगता है? कुछ have you heard of this sort of thing or is this new to you? जो मैं अभी बोल रहा हूँ, is this new, is it random or have you heard of this sort of thing before? Think about it. If you have, that's great. If you haven't, that's also fine. There's no right answer or wrong answer here. मैं आपसे पूछ रहा हूँ, मैं आपका opinion जानना चाहता हूँ कि what is it like? What do you think it's, is it useful? Is it not? Have you done this before? If you haven't, don't worry. हम लोग discuss करेंगे. Yeah? Don't worry about that. Give me your inputs. I'll wait for it. It's all right. We have all the time in the world. So the main thing here is that stuff can actually give you different, very, very different outputs than what you imagine. Okay, that's where I'm getting to. I just want to know your ideas as to आपने क्या experience किया है अभी तक. If you experience it or not is what I want to know. ठीक है. Okay. So what we will do, hold on, I'm trying to find the chat फिर से एक minute. If dispersion, Tyndall effect, okay, all right, आसपास के particles visible हो जाएंगे. Okay, this is very interesting. बहुत awesome inputs मुझे मिल रहे हैं. This feels like a normal class, huh? Where you students give me such amazing inputs. Okay, we'll do something interesting. Normal gas में कुछ नहीं होगा ना? Normal gas में कुछ नहीं होगा. Normal gas में तो भाई गैस मेरे आसपास है. I don't see anything. कुछ नहीं दिख रहा है मुझे. But now if I heat up the gas, तब क्या होगा? अगर if I heat up the gas, क्या होगा? That is where things get interesting. Hold on. मैंने यहाँ पे label थोड़ा उल्टा कर दिया. I'm just fixing the label in real time. What I have here is going to be a hot gas. एक मिनट हाँ. Eraser and ये है hot gas. Okay, and this is white light and cold gas. All right, I fixed it in post. Random motion of particles increases. Okay, student, I like that. Ash is saying something very interesting. Random motions of particles increases अगर मैं गर्म करूं, ठीक है. But इस सीन में जो मैंने सीन आपके लिए ड्रॉ किया है, उस सीन में कोई फर्क पड़ेगा क्या? Okay, let's see. Hold on. It's just getting this thingy out here. Okay. Cool. All right. ठीक है. If I heat up a gas, something crazy happens. I take a hot gas. This is what happens, which is like weird. Like what? But this is really what happens. So instead of seeing the whole spectrum, now I see random lines. That's all I see. I see some random lines. Yeah. रैंडम मोशन ऑफ पार्टिकल्स विल इंक्रीज. वो आप बिल्कुल सही बोल रहे हो. अगर मैंने किसी चीज को गर्म किया, उसके पार्टिकल्स इंक्रीज, उसके जो है मोशन विल इंक्रीज. बट रिमेंबर व्हाट आई एम डूइंग इज कि देयर इज सम हॉट गैस एंड व्हाट इट इज डूइंग इज कि उसमें से कुछ चीजें निकल रही हैं. बट नाउ इंस्टेड ऑफ गेटिंग द होल कंटिन्यूस स्पेक्ट्रम आई एम ओनली गेटिंग सम लाइन्स, नॉट अ कंटिन्यूस स्पेक्ट्रम एनीमोर. आई हैव गॉट लाइन्स. Line 1, line 2, line 3, line 4, line 5. In this setup, whatever this setup is, I don't know what the gas is. Let's say this gas is hydrogen. ऐसे hypothetically बोलते हैं ये hydrogen gas है. Hypothetically, right? So when I took white light, I got a continuous spectrum. ठीक है? When I took white light, I got a continuous spectrum. But now I've got a hot gas, and now instead of getting a continuous spectrum, I've got certain things. So what is actually happening? Hot gas matlab something gets excited, let's say electrons get excited and they fall back down. When they fall back down, क्या होगा? Energy has to be conserved. So energy कैसे conserve होगी? It will be given off as light. It will be given off as light. ठीक है? अगर टाइम पास करोगे तो टाइम आउट तो मिलेगा भाई. What are you behaving like Gandhi? What do I do? Why do you ban me? क्या यार, तुम लोग भी टाइम पास करते हो ऑनलाइन. ठीक है? Back to the point. How did we get these lines? You've got a hot gas, which means मैंने उसको excite किया है. And then after some time it will fall back down. Whatever excitation happened, right? Fall. अगर वो वापस नीचे गिर जाएगा तो वो extra energy कहाँ जाएगी? Come out as light. But the interesting thing is, this is proving that I've got particles. And सबसे बड़ी चीज कि not wave. And I'm like, bro, the topic of this video is is wave, right? Nature of light. And I'm ending it with saying कि this is not a wave. Interestingly, when I take a cold gas, इसका exactly उल्टा होता है. When I take a cold gas, okay, what I've got is, पहले I've got light. 1, I've got light, okay. 2, I've got this gas. And 3 is I've got this slit. So, this is the order, okay. मेरे पास, say, I've got white light, जो मेरा, the light that's lighting up this room. उसके बाद मैं रख रहा हूँ gas, और उसके बाद है prism. उसमें, these lines are missing. Missing lines. मतलब, those lines were absorbed, right? Those energy bands, I can expand saying that those energy bands were absorbed. Does this make sense? People who are still here, I know, ये थोड़ा भारी है. Aryan, student, Ashutosh, Swap, Litti Sahab, Playboy ji, wow, what a brilliant name. You made me say it, huh? Carty, Alpha Beta, और कौन थे ऊपर? अर्नव जी जो बोल रहे थे, नसरत, just checking in. All right. So, two things happened. When I took a hot gas, I got certain lines. And when I take a cold gas, उसका exactly उल्टा हुआ. वो lines absorb हो गई. So, absorb हो गई, तो this is called the absorption spectrum. Okay. And since these in a hot gas were being emitted, इसको बोलते हैं emission spectrum. ठीक है? All of this and more we will study in later sessions. All of this and more we will study in the later sessions. Wow, that's very nice, student Ash. You've been listening to amazing things. We'll talk about that. That's a little bit beyond the conversation that we can have on this thing right now. So we'll talk about that. Ping me on, the Discord server. Ping me either there or on Telegram or somewhere else, and we'll talk about that. All right, photonic spectrum and all that. All right. So that was a general thing. Now a blank body is a really special thing. Okay, a black body is something that's not black in color. Black in color means, right? Black मतलब जो हर light को absorb कर रहा है. But black body means it absorbs all radiations, not just invisible light. Okay, black body is different from a regular kala substance. Like, no, it's not black color. It's black means it absorbs all radiation. Okay, great. So heated body radiation का मैंने आपको idea दिया ऊपर से, ठीक है, एक गैस को लेके. Okay. If you heat any body, some sort of radiation is given off. Radiation मतलब गरम है ना, गरम लगता है तुमको उसके 5 हाथ रखने, मतलब that is some radiation in the form of heat. Metal becomes white hot, red hot, कुछ color दिखते हैं, and radiation is given off in visible spectrum, तब वो दिखता है. But what if some crazy radiation is being given off that you cannot see, which is true, right? Even when you can't see it, गरम आपको उसके आसपास लगता है. That is known as infrared radiation. Please revise what are electromagnetic waves. Infrared मैंने अभी सबको दिखाया था. That heat is basically infrared radiation. Okay, that's because there is vibration. वो कोई बोला था ना, मैंने पूछा था गरम करो क्या होता है. You guys said, who said, ऊपर किसी ने बोला था ना कि वो Tyndall effect नहीं. I missed some of that comment. Sorry. Hey Tanishq, what's up? What's happening? नहीं, student Ash, please speak extra. As long as you are inquisitive, anything is welcome here. If I feel कि इस क्लास के लिए ज़्यादा है, I will tell you to reach out to me on Discord or on Telegram and I'll give you stuff to read. That is my guarantee to you. I will never say कि ये out of syllabus से मैं नहीं बताऊंगा. I will never say that. But because I have a constraint of time, I will tell you यार इसके बारे में बात हम लोग बाहर करेंगे out of this. And I'll give you links to it. It's not time pass. You can ask anybody who has ever pinged me. I always give you resources to read. We'll do that. Okay. But thanks for keeping the conversation going. Keep asking questions. It's lovely. ठीक है. Okay. Now, when you heat a body, radiation is always given off and it's not necessarily in the visible spectrum. आप अगर किसी को बहुत गर्म करते हो, वो glow करने लगता है, right? Red hot, white hot. Okay, cool. Now, I will design a system that does something crazy. Okay, it's an ideal system that absorbs and emits all frequencies. का मतलब क्या हुआ? देखो यार, if I've got a silver color metal ball, पहली बात है कि वो सिल्वर कलर का है, मतलब वो कुछ चीजें अब्सॉर्ब कर रहा है, कुछ चीजें रिफ्लेक्ट कर रहा है. इट्स नॉट एन आइडियल सिस्टम. बट इफ यू गेट अ ब्लैक कलर्ड सिस्टम, दैट मीन्स इट्स अब्सॉर्बिंग एवरीथिंग एंड इट इज एमिटिंग एवरीथिंग. बट द ब्लैक कलर, फिजिकली ब्लैक कलर मीन्स वो विजिबल लाइट का स्पेक्ट्रम अब्सॉर्ब कर रहा है. बट अ ब्लैक बॉडी मीन्स दिस क्रेजी थिंग वेर यू गॉट दिस सिस्टम जहां पे लाइट सिर्फ एक जगह से जा सकती है. लाइट मतलब रेडिएशन, एक्चुअली नॉट लाइट बट इन फैक्ट रेडिएशन सिर्फ एक जगह से जा सकती है एंड इट रिफ्लेक्ट्स सो मेनी टाइम्स दैट नन ऑफ इट कैन एस्केप एनी रेडिएशन. ओके, व्हेन आई एम ड्राइंग दिस, इट्स नॉट लाइट, इट इज रेडिएशन. मतलब बी इट radio wave, be it gamma ray, be it anything. So it's a hypothetical situation because to build a system where gamma rays cannot penetrate is crazy. You've got to get lead lining and all of that, etc. etc. खैर, अब ये सब करो and then you do this crazy experiment. In real life you get this sort of a spectrum. ठीक है, ब्लैक बॉडी का स्पेक्ट्रम इस तरीके का दिखता है, which means कि at different temperatures, these are crazy temperatures, see 3000 Kelvin, 4000 Kelvin, 5000 Kelvin, इस पे बॉडी अलग अलग कलर की होती है. At 3000 Kelvin, it is not in the visible range. At 4000 Kelvin, it looks like it's reddish. And 5000 Kelvin, it looks like it's going to be violet. It's crazy, crazy, scary colors. And you're like, bro, what are you talking about? 5000 Kelvin तो यार temperature sun का होता है. तुम कहाँ 5000 Kelvin देखो life में? You may ask me this question. It's a valid question. So these temperatures are A, simulated in a lab, like on a computer, or B, they do it and these very, very small particles that we're yet to discover, we'll talk about, they get to these temperatures for a very, very small fraction of a second just to measure this experiment कि भाई ये होता क्या है. And how do I know this color? Frequency, wavelength, etc. etc. ठीक है? Lol, absolutely. It becomes blue at high temperature. Yeah, sure. ठीक है. This is real. Okay. But हम लोग जो classical theory है, भाई, this is something called as a quantum catastrophe, I want to call it. Let me look up what it's called. Hold on, मैं भूल रहा हूँ. Black body radiation catastrophe. I forgot what catastrophe. What was it? So you can read. Ultraviolet catastrophe. That makes more sense. It's called the UV catastrophe. अगर किसी को और पढ़ना है तो. मतलब कि for very, very low wavelength or high frequency, the classical theory fails, miserably fails. Okay, classical theory मतलब जो wave हम लोग अभी पढ़े ना, that completely fails. So what do we need? We need this. This is why we need this quantization वाला business. Planck भाई साहब ने अलग से काम किया, आइंस्टाइन ने अलग से काम किया. Okay, but both of them अलग अलग से they figure out कि भाई it has to be quantized. But Einstein did not get the Nobel Prize for this. He got the Nobel Prize for the photoelectric effect. If you want to read up more on this. So some crazy things happened in the 1900s. Okay, this was and which also led to the atomic bomb being created, sadly. That's one of those things, right? With great power comes great responsibility. But anyway, this is an introduction to this whole particle nature of radiation. I know. Thank you for sticking around if you have done so for this till now. बहुत ज़्यादा भारी चीज़ें हैं, I understand. We'll get to some cool numericals and all that, but the first session is an introductory session where we're just figuring things out. So what did Planck do? Planck said कि भाई energy is definitely quantized, मतलब कि energy packets में होती है, ठीक है? And the variation of intensity और wavelength इन सब चीज़ों की बात की. And most importantly, he said कि छोटे छोटे packets होते हैं energy के, which he called photons. Okay. And how do you decide उसकी energy? He said that the energy was proportional to frequency. Nu, by the way, now is frequency. Okay. And ये इसका hint मैं आपको दे ही चुका हूँ पहले कि gamma rays had the highest energy, which you already know. You have heard of this. It's called non-ionizing radiation, जो ionize नहीं करता है, ठीक है? Gamma rays and microwaves are less energy, कम energy वाली हैं. इसीलिए they die out very easily. या microwave बहुत दूर तक जाता नहीं, but gamma rays बहुत दूर तक जाती है, बहुत high energy waves हैं. So E was proportional to this, and the proportionality constant was a very, very small number known as the Planck's constant. Okay, this is the number right here. If you feel like I'm going a little fast on this because this is theory, there's not too much I can add to this at our level. ठीक है? Maybe एक साल बाद we can revisit this and I can do maybe another session with you guys with Atkins. Okay? इसमें बुक में in Atkins it has wonderful derivations, but all of those derivations require a little bit of math जो आप लोग अभी तक आपने नहीं सीखा है. Maybe 1 year down the line we can do that again. Okay. Any questions, any doubts on anything so far? So if I have one photon of energy, what is a photon? I think Sanskrit में भी कुछ बोलते थे. Particles of energy. I forgot what it's called, but this is also there in Sanskrit in the Vedas. Okay, they talk about particles of energy like light के particles. So one photon can have an energy that is h times the frequency. That's it. उससे छोटा बड़ा नहीं हो सकता है. Okay, बड़ा हो सकता है. बड़ा कैसे होगा? एक के बजाय 2 photon, 3 photon, 4 photon. What happens if you increase photons? You increase the intensity of light. Increase photons means increasing current, right? In a way. Or current नहीं, sorry. ये क्या लिख दिया? Current को लिख दिया. My mind is in somewhere else. Increasing intensity. ठीक है? ज़्यादा photon मतलब कि ज़्यादा light मतलब intensity बढ़ रही है. That's what you do know when you have you used a light where you have control over the power of light? You go from 5 watt to 10 watt to 20. अच्छा phone में, हाँ phone में है ना ये. Phone में you have this what do you call this thing? कहाँ गया ये? Torch. Torch में intensity होती है ना? When you're going from this to this to this, I don't know if you can see the intensity increasing, but that is basically increasing photons. All right, it's not 1 or 2 photons. It's 10 power 23 or whatever moles of photons and etc etc. Okay, I think आज थोड़ा भारी हो गया. We'll end this session. Hi Bond साहब. bond chemical bond. आज थोड़ा भारी हो गया. We'll end this session with a very small thing because ये फोटोन, ये जो वैल्यू h की वैल्यू कितनी थी 6.6 into 10 power minus 34. न्यू की वैल्यू क्या होती है फॉर विजिबल स्पेक्ट्रम और एनीथिंग? इट्स अबाउट 10 power 14 to 10 power 15 hertz. So even if I multiply both of these, I get a very small number. So इसीलिए I need a new unit of energy that is more relevant to the charge of subatomic particles. So electron into volt. Remember V into Q was energy. So electron volt मतलब एक इलेक्ट्रॉन का energy if you take a potential of 1 volt. Okay, so E, you know the charge is 1.6 into 10 power minus 19 coulomb. ठीक है? So 1 electron volt is 1.6 into 10 power minus 19 joule. Okay, cool. बस यहीं पे खत्म करते हैं यार. Next वाले में I'll do a small derivation on E equal to h nu and we'll talk about particle nature of light. I have white hair. Thanks for asking. You guys ask some weird questions. Is that lighting on? I've had white hair since I was 15 or so, and it has slightly increased with age. अरे वाह swap. Lovely question. Yes, lol, absolutely right. बिल्कुल सही. What to study for the next session? Okay, I'm going to do you a favor. You asked me the best question of them all. So I'm going to share my screen. I'm going to open up NCERT and tell you वहाँ से क्या पढ़ के अगले सेशन में. बहुत सही सवाल पूछा. मैं तो भूल ही गया. सबसे जरूरी सवाल. I completely forgot about this. NCERT atomic structure. आज का सेशन थोड़ा सा लंबा हो गया. We'll try and keep it within time for the next one. Hold on. I'm just going to share my screen. I will get this guy here. I will get this guy here. And let's make it full screen. Let's do this. Okay. Okay. OBS will now show you my screen. Screen capture. Okay. Display capture. No, not this one. Window capture. Brave browser, live streaming, no, not this. Unit 2, मिल गया. कोई मिल गया. Okay, this is it. You can see my screen now, right? मैं नहीं दिख रहा हूँ अब लाइव. मैं नहीं दिख रहा ना? रुको मैं दिखूंगा अभी. मैं दिख रहा हूँ अभी. स्क्रीन भी दिख रही है. सब wonderful. Simply wonderful. Okay. Cool. Now I have put myself in a predicament. ठीक है, चलो. Let's see. I have a mouse. All right, the session is done, guys. If you want to carry on. But somebody asked me a wonderful question, so I'm trying to answer it. Okay, the wonderful question was, what do we study for the next session, and what have we covered so far? ये सब आपके syllabus में नहीं है. All of this that you see is not in your syllabus. Okay, let me start with what we did today. आज हमने क्या किया? Thomson model ये सब syllabus में नहीं है. आगे बढ़ा जाए. Yeah, wave nature. See, this is page number 2015-16 का page number है 34. From the 2015-16, page number is 34. Okay. All right. We've covered page number 34 key ideas, electromagnetic spectrum, all of these things that go on from here on to right about here. Okay. and I've given you a little bit of a background about all of this. For the next session, you can study this. Okay, black body का भी radiation हमने बात की है. Next one के लिए let's do this photoelectric effect पढ़ के आइए, and let's also do, shall we do photoelectric and dual nature of electromagnetic radiation. Let's try and do both of these ideas. ठीक है, ये दोनों चीजें हम लोग करने की कोशिश करेंगे, and we'll do a few questions also. I'm doing just 2 or 3 pages of NCERT in a class because atomic structure बहुत भारी चीज है, and I've given you some more things than what is in NCERT or will ever need for JEE and NEET, but mainly to give you a bit of an idea. ये spectroscopy also I've already told you. Okay, emission absorption spectroscopy, I've more or less given you an idea of this also. ठीक है, all right, great questions. You are all wonderful students, and because you asked this wonderful question, a lot of students are going to benefit from this. So thank you for asking. Thank you for asking this. ठीक है, हम लोग मिलते रहेंगे आगे. फोटो लेक्चर पे पढ़ के आइए, एंड ऑल्सो डुअल नेचर ऑफ मैटर. ठीक है, लेट मी क्लोज दिस वीडियो आउट. ऑल राइट, थैंक यू सो मच फॉर योर टाइम. मिलते रहेंगे हम लोग. सी यू. बाय द वे, इफ यू नो हैव सम फ्रेंड्स हु आर प्रिपेयरिंग फॉर नीट, आस्क देम आल्सो टू कम चेक आउट दिस इटसेल्फ. इसी चैनल पे हम लोग 11th का कंटिन्यू करेंगे. एंड इफ यू हैव फ्रेंड्स प्रिपेयरिंग फॉर जेई फॉर द 12th ग्रेड, कम टू द नीट चैनल, वहां मैं सॉल्यूशंस कंटिन्यू कर रहा हूँ. ठीक है, स्वॉप जी, अगर आप जेई की तैयारी कर रहे हैं देन आपको एनसीईआरटी पढ़ना वुड बी अ गुड थिंग. ओके, स्वॉप. इफ यू आर प्रिपेयरिंग फॉर महाराष्ट्र सीईटी देन गो अहेड, महाराष्ट्र की बुक पढ़िए. एब्सोल्युटली. ओके, सी यू ऑल. बाय, गुड नाइट, हैव एन ऑसम मंडे. मिलते रहेंगे. थर्सडे को इज द नेक्स्ट क्लास. ओके, बाय, टाटा.